This video examines the operation of a self-cleaning separator, a critical piece of equipment found on modern seagoing vessels. This presentation is prepared by Assistant Professor Manny Vannon S., a Marine Engineer Officer and Naval Architect with extensive experience in the Merchant Navy. On-board ships, self-cleaning separators are now the standard, with processes fully monitored by a programmable logic controller, or PLC. Solids, or sludge, are periodically discharged, requiring a temporary interruption of the separation cycle while the bowl operates at full speed. The discharge process involves opening the sludge ports at the bottom of the bowl. This automated sequence ensures efficient operation without needing manual cleaning. This cycle is crucial for maintaining the cleanliness of fuels and oils used in marine engines, preventing premature wear and tear on ship components. During the separation phase, the chamber below the sliding piston is filled with water. The rotating bowl generates high centrifugal pressure, which acts on the annular and sliding pistons to keep the bowl sealed. This hydraulic mechanism, utilizing the operating water, provides the force necessary to maintain the structural integrity of the bowl during high-speed rotation. The system relies on precise water management within the rotating assembly to function correctly. The high centrifugal pressure in the closing chamber, combined with the large surface area of the sliding piston, creates a strong upward closing force. This seals the piston against the polyamide gasket. This firm seal is what keeps the bowl closed and ensures that the separation process proceeds without leaks. By maintaining this closing force, the separator reliably processes fluids under intense operational conditions. Once the separation timer finishes, the PLC initiates the cleaning cycle. First, displacement water is added to the bowl to prepare for the discharge. Next, the operating water valve opens, allowing water to spray into the closing water chamber, initiating the change in hydraulic pressure. This stage is a critical transition point in the automation of the separator's self-cleaning cycle. Finally, as the closing chamber fills, the water overflows into the chamber below the annular piston, which is specifically identified as the opening water chamber. When the opening water chamber fills, the annular piston begins to move upwards. This happens because the downward surface area of the piston and the resulting force is greater than the surface area on the top. As a result of this pressure difference, the closing water is effectively drained into the central chamber, allowing the piston to move. This movement is a key phase in the cycle, as it prepares the bowl for the discharge of accumulated solids. The hydraulic balance within the bowl is carefully calibrated to ensure this transition happens reliably and at the correct time. With the piston displaced, the bowl is forced open by the internal pressure generated by the fluid within the bowl. The sliding piston executes its downward stroke rapidly, taking only a few milliseconds to complete. This rapid movement quickly opens the slot-shaped sludge discharge ports located at the bottom of the bowl. The bowl performs this entire ejection process while still rotating at its full operational speed, ensuring maximum efficiency. The hydraulic system's fast-acting nature ensures that once the ejection is complete, the bowl is left clean. Because an empty bowl does not generate an opening force, the system naturally resets, and the sliding piston moves back up into its sealing position. Throughout this phase, the annular piston remains in a floating state, ready to return to its original position. The operation of the water valve is precisely controlled by the PLC, following the total ejection timer settings. The remaining opening water is drained through dedicated nozzles in the bowl bottom, allowing the gasket to reseal. The annular piston then firmly seals the polyamide gasket against the bowl bottom, completing the closure. Finally, a small closing water impulse is applied to maximize the closing force, and the system automatically resumes the separation cycle. The operating water valve will spray a small spurt of water, controlled by the closing water impulse timer, into the closing water chamber. This final impulse ensures the highest possible closing force for the bowl. With the cycle completed, the cleaning phase is finished, and the separator is ready for continuous duty. The separation cycle then restarts automatically, governed by the PLC to maintain optimal performance. This automated, self-cleaning process is fundamental to modern maritime fuel treatment technology. Thank you for joining this overview of self-cleaning separator operation. Please subscribe to the Seaman Sankar channel for more marine engineering educational content. Thank you for watching. For further insights into marine equipment, explore our detailed series on centrifuge technology.